For question 14, we are told that we have a force F that is used to pull a box weighing 20 newtons up a smooth incline as shown. The work done by F increases the GPE of the box as it rises through a height of 3 meters. Okay, and what we are asked, what is the minimum value of F needed to move the box up the slope? So for this kind of question, I would typically advise my students to use the expanded conservation of energy formula. So the expanded conservation of energy formula will be GPE initial plus the KE initial plus the work done due to any accelerating forces. Now, just to elaborate, an accelerating force is what happens when we have the force and the distance, okay, which are both acting along the same direction. If the force and the distance are both forward, okay, for example, then we say that this particular force is an accelerating force. Alright, so this is going to be equal to the final GPE plus the final KE plus any work done against resistive forces such as friction or air resistance. Now, how do we define a resistive force? Essentially, just like friction, if there is some distance that is moved by the block, okay, say like this block moves forward distance, okay, but friction is going to act backwards. So if we have a force and distance which are acting opposite to each other, then we define that as a resistive force. Now, because this question tells us that we have a smooth incline, essentially there are no resistive forces. Okay, now initially the box is on the ground, so we assume that there is no GPE to begin with. And one more thing is that we are not given any information on the kinetic energy of the box, so we're going to assume that the box is pulled up at a constant speed. Okay, the box is pulled up at a constant speed. Okay, if the box is pulled up at a constant speed, this means that the initial KE is equal to my final KE, and therefore these two will cancel each other out as well. So from here, we actually have the work done due to the accelerating force of F, okay, which must be equal to my GPE gain of the box, okay, the GPE final of the box. Now, what is the work done by the accelerating force? We have F multiplied by this distance over here, but this distance over here is just going to be 5 meters. If I use Pythagoras theorem, 4 square plus 3 square must be equal to 5 square. So we have F times 5 must be equal to the GPE gain. So GPE gain is going to be mgh, but mg has already been given to us as 20 newtons. So we have 20 newtons multiplied by 3 meters. Okay, so we have F, which is equal to 60 divided by 5, so we have 12 newtons, right? So the minimum value of F is going to be 12 newtons, which is our answer A.